Hi, welcome to Sir Dave Smart. In this video, we shall be looking at linear inequalities in two variables. This particular question was gotten from NECO past question booklet. Show on the graph the region bounded by the three inequalities. Show on a graph the region bounded by the three inequalities using a scale of 2 cm to represent 1 unit on both axes. Inequalities are 2x plus y greater than or equal to 2, y plus 2 less than 2, and x minus y less than 1. So let's kickstart. So we'll start with the first inequality, 2x plus y greater than or equal to 2. We'll draw the boundary line for 2x plus y equal to 2 by assuming that x is equal to 0 and assuming that y is also equal to 0. So when x is equal to 0, we have y equals to 2. So for this point, 0, 2 are the coordinates, and then when y is equal to 0, 2x is equal to 2, x becomes 2 divided by 2, x becomes 1. So for this point we have 1, 0. Okay, so let's draw the boundary line for this inequality. So the scale says 2 cm to 1 unit on both axes. 2 cm to 1 unit on both axes. So this is 1, 2, 3, 4. This is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. 2 cm to 1 unit on both axes. So for this first point, when x is 0, y is 2. When x is 0, y is 2, 1, 2. Let's number it 1. When x is 0, y is 2. And then the next one says when x is 1, y is 0. This is 1, this is 2, this is 3. When x is 1, y is 0. The inequality says greater than or equal to. So we're going to draw a thick continuous line that will pass through those 2 points. Okay, so let's carry out that test. When x is 0 and when y is 0, we have 2 bracket 0 plus 0 greater than or equal to 2. This will give us 0. 0 greater than or equal to 2. So is 0 greater than or equal to 2? Remember, we are going to shade the unwanted regions. We're going to shade the unwanted regions. So So 0 is greater than or equal to 2 talks about this region. So we're going to shade the unwanted region. So next we'll move to y plus 2. Sorry, the second inequality says y plus x is less than 2, not y plus 2. Sorry about that. So y plus x less than 2. We'll draw the boundary line for y plus x is equal to 2. So when x is 0, we have y is equal to 2. So the coordinates for this point is 0, 2, and then when y is equal to 0, x is equal to 2. So the coordinates for this point is 2, 0. So let's plot these points on our graph. 0, 2, that's here, and then 2, 0, that's here, less than. So we're going to use broken lines. Break lines. Okay, so let's carry out that test. When x is 0 and when y is 0, 0 plus 0 less than 2. So we have 0 is less than 2. 0 is actually less than 2. So this is the region that talks about 0 is less than 2. So we're going to shade above that line. So next we'll move to the third inequality. The third inequality that says x minus y is less than 1. So we're going to draw the boundary line for x minus y equal to 1. When x is 0, we have y equal to minus 1. So for this point we have 0, minus 1. Then when y is equal to 0, we have x is equal to 1. That is, if you put 0 here, x becomes 1. So here we have 1, 0. So let's plot that on our graph. X, minus 1. Minus 1 is this point here. Then 1, x. 1, 0. So this is the second point. So we're going to draw another broken lines through these 2 points. So let's conduct the test by making x 0 and y 0. So we have 0 minus 0 is less than 1. 0 minus 0 is 0. 0 is less than 1. So 0 is less than 1 talks about this region, the origin that entails the origin, this region. So we're going to shade this part of the line. So the region arrow is bounded by these three inequalities. So this is 2x plus y equal to 2. And this is y plus x equal to 2. And this is x minus y equal to 1. So this region is bounded by these three inequalities.